Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video discusses how to find the standard deviation. Let's get started. In statistics, we use measures of variation to describe the spread of the data within a distribution. This feature describes an important characteristic of the distribution of our data that complements the measures of center. Knowing where the data are centered and how they're spread out from that center provide a basic but essential description of a data set. Now, just as the mean is the most commonly used measure of center, standard deviation is the most commonly used measure of variation. Standard deviation is simply a measure of how much the values in the data set deviate away from the mean value. Standard deviations can characterize both samples and populations, but how we calculate them is slightly different for each one. So if we're looking for a sample standard deviation, we denote that with a lowercase letter s. And we use this magnificent equation that you see before you. We have the square root of the sum of the squares of x minus x bar divided by n minus 1. Remember that x represents the individual data values. We're going to subtract from each individual data value the mean value x bar. Then we're going to square those differences. And then we're going to add the squares of those differences together. And then we're going to divide that number by n minus 1. And let's just one less than the sample size and then take the square root. So if you're calculating this old school style by hand, this is an enormously tedious calculation. I remember calculating it by hand when I was in college. I did it for a little while, and of course I had one of those calculators where the function was built in. So I just used that, pressed the button, and boom, came out for me. There is this so-called shortcut equation, which is supposed to be much easier to use when you're actually calculating it by hand. But hey, you know what? I'm sorry. It's still a tedious calculation. I suspect most, if not all of you, will be using technology because you've joined the 21st century. And hey, there's no shame there because that's my preference too. Now, if you're looking to calculate a population standard deviation, then this is the equation to use. Now, notice the differences here. Okay, instead of a capital letter S to represent the population, where we have a lowercase letter s here to represent the sample, here we have the lowercase Greek letter sigma. Why we don't use a capital letter S is beyond me, but we certainly can't use a capital Greek letter sigma because here's the capital Greek letter sigma here. It's a mathematical symbol for summation. So this is what it is. Also notice there's no n minus 1 here in the denominator of our fraction. Okay, it's just n. Okay, now other than that, the way we calculate standard deviation is pretty much the same for samples and populations. Okay. Again, I seriously doubt you'll have to calculate any of this by hand, but it is good to know what the computer is doing to give you the number it gives you. And if you're wondering what Oreos have to do with all this, the answer is nothing. I just like chocolate cookies. Okay, standard deviation has a number of properties that we need to be familiar with so that we can correctly interpret standard deviation values. Okay, first, standard deviation measures a variation of all the data values from the mean. It takes into account all the data values that are in the data set. Next, standard deviation values are always positive. Notice in the examples here on the screen where one distribution has a standard deviation of 1, the other distribution has a standard deviation of 5. These are both positive values. That's because we're looking at how far a data point is away from the center point. This distance is measured from the center out to whatever point you're looking at. So even if the point is located on the left side, which would be in the negative direction on a number line, you're still measuring out from the center point. So all these distances are going to be positive. Thus, standard deviation values are never negative. They're always positive. Standard deviation can also increase dramatically with the inclusion of one or more outliers. It's not what we would call a resistant measure of variation. It is as it has that same sensitivity that the mean has when you're running the calculation, because it considers every data value. Now, the units of standard deviation are also the same as the units of the original data values. Okay, so look at the example distributions here. Okay, both of these distributions are listing values for density. Okay, so the standard deviation would take on the same units for density that you ascribe to, whatever individual data point you have. Now, with all that in mind, here's how to interpret the standard deviation themselves. The lower the standard deviation, the more closely packed together the data is, and so it makes the shape of a distribution more pointed and narrow, like you see here on the left. Okay. Conversely, if the standard deviation is a higher value, then the data becomes more spread out. Okay, and with the shape of the distribution is more flat and wide. Since standard deviation is always positive, you could say that the closer you get to 0, the more narrow and pointed your distribution will be. And the farther away you get from 0, then the more spread out and flat your distribution will be. Let's look at our previous example of chocolate chip cookie counts and cookies to illustrate how to calculate standard deviation. Here we've got 5 cookies that we sampled, and we counted the chocolate chips in each of these cookies. Of course, because the chocolate chips and the cookies are not always on the surface, there's some destructive testing involved to get a proper count. Now, if you're thinking that it's the kind of destructive testing I would enjoy, you'd be wrong. It's torture, man. You have to take little nibbles so you don't accidentally chomp through a whole chocolate chip and miscounting it in your chocolate chip count. What I want to do is chomp down, man. Nibbling is like total torture. Okay, to calculate the standard deviation, the first thing we have to do is find the mean value. Okay, that's part of the equation for calculating the standard deviation. So here we calculate the mean value. We get that number ready to go. Okay, next, we're going to use the standard deviation equation. So here's our equation for sample standard deviation. The 5 cookies we have represent a sample, not the population. So we need to use the right equation. Use the one for the sample. Now, when we substitute values into the equation, here's what we get. Notice where all these numbers are coming from. Okay, we have 22 that comes up first. It's also the first value that we use to calculate our mean. We're going to subtract the mean value from that first individual data value. And then we're going to square the difference to get the first value that we add together. You can see how this is quickly becoming tedious, which is why many of us will be like, Cookie Monster, just get me to the end, man, so I can eat more cookies. However, if you're the count, you won't mind going through this process because you love numbers. I say, why can't we have both? Why can't we be the count and learn how to calculate standard deviation and then join Cookie Monster for cookies and milk? Assuming, of course, he hasn't eaten all the cookies before we get done with our calculation. So we punch out these numbers on our calculator, and out comes the square root of 11.2 over 4, which gives us 1.7. 1.7 is then our standard deviation. Now, earlier I mentioned calculating the standard deviation with technology, which for many of us translates into StatCrunch. You're going to calculate this the same way as you would any other statistic like the mean or the median. But there's one special feature you need to know. StatCrunch has 2 standard deviations in its list of stats to select for calculation. One is for the sample and the other is for the population. So the standard deviation for a sample is found near the top of the list and appears as simply standard deviation. The one for a population is found near the bottom of the list and appears as an unadjusted standard deviation. So when you're working your assignments, you need to be aware of whether you have a sample or a population so that you calculate the right value because they are slightly different. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountAcademy.com. Thanks for watching. I'll see you in the next video.